Hey, what's up YouTube? So here we are, end of week 2. We did the easy week number 1. Week number 2 has been a lot harder, my opinion. Maybe not to some of you guys, but for me it's been a while on the math. And some of this closed form mathematics where we're updating these alpha A and alpha B parameters. So yeah, let's do day 14 and then we'll move on to week 3. So maybe just to recap a little bit. So week 1, that was just the classic degree per minute model. Something that we looked at a long time ago. We looked at the decompiled code from Tritium's optimal start, and they're just doing this simple degree per minute, and then they're only holding the last day of data. Yesterday's degree per minute data, yesterday's degree per minute data. But our model 0, using this linear degree per minute, we're actually traversing using 15 days of data, and then running an exponential moving average on there. So we're kind of averaging out all this data, and we kind of could have potentially a little bit better performance than just using yesterday's data. So maybe we'll just run this. So I might do model 0 tutorial. So this is kind of interesting. So this is just made up. It would be really fun to get some real actual data, and we just kind of plow through the data with just calculate our degree per minute, and then we use this is actually our exponential moving average code right here. So this kind of smooths everything out, and then if we had a new we use that model on tomorrow and it was 10 degrees off, and then this is what our model calculates. We would calculate 50.1 minutes that the HVAC system needs to start to condition the zone before occupancy with a 0.1196 degrees per minute, which is kind of pretty close to what I see in the field. So if I take this same data, and I'm kind of trying to finalize my model 1 tutorial, same data, same made up data, and then we have this fancier model, which is actually using a squared delta temperature. So this is and the research shows that the model is actually curved. So when the zones, when the building's colder or warmer, and that delta temperature between the zone temp and occupied or occupied heat or occupied cool set point is bigger, that the rate that it takes to warm up that zone isn't a perfectly linear curve like our previous model, which just assumes a flat line, but we actually need a curved line, which would be this quadratic model that's kind of stems from this squared delta temperature. So in order us to calculate this now, which gets into that closed form mathematics, just like the model 0, we plow through this and we sum up all the model parameters and equations in Python. Here's our delta temperature, and this is actually just a little checker that there's not enough variation in the delta temperature to fit the model, which we do have in the Java version 2 in the program object. And then also something that we do at the end of this, I think the PNNL paper recommends taking a rolling average to every time that you solve the equation and you come up with a new regression result, that you actually smooth these parameters out a little bit. It helps the model perform a little bit better. So if we just do model 1 tutorial, looks a little bit different. This is our model equation based off of all of our data here. And after it's smoothed out, these are actually our parameters that get updated. So the model is tuning itself by these A and B parameters, which we solve for in here. And then the PNL just recommends that you do, once you solve these, that the data can be kind of messy, and you can kind of smooth them out a little bit better from you use yesterday's data to smooth out your new alpha parameters, so it's not, the model doesn't jump around with big, super big amounts. So yeah, that is about it. I think like it would be kind of fun, even though this is just like made up data, so just pretend copy this over to our model, this model. So we have this, so this is copied over from our model 0. So we can do another prediction, pretending that it's tomorrow's prediction, that same 10-degree cold morning before the building starts, and we're 10 degrees off from set point. What are the minutes that we need to predict? So instead of just doing that linear model of degrees per minute, now we use this guy. So this is we could actually, I'm almost kind of curious as I copy this. So I'm just going to say predicted minutes. I can blast away that because that was our old model. So here we go. So we do alpha new times the delta squared, which we could probably throw together in some Python. So let's times that by, I think I this. So if we wanted it to do our alpha new squared, I think we would just do this. Did I do that right? No, this would be our delta t squared. And then our b parameter plus our b parameter, we just add this. B new, A new, B new. So the units would be minutes would equal degrees, 100 degrees per minute. This would be delta temp squared. Actually, I think this would be, maybe I'll just say degree F squared minutes. Because this parameter was just a minutes. This is just some fixed minute units in minutes. And then this would be yeah, I think this is degree temperature, degrees Fahrenheit squared. So let's see what this would be. Oh boy, doing something wrong here. Predicted minutes would be 4 billion minutes. So, okay, so here we go. Or no, I see divided by. Or am I getting this wrong? Maybe I'm getting something wrong here. So I'm pretty sure this is our regression equation. So maybe this is just a bad example to use with data. So, well, let's just ask ChatGPT, what would be our units? Here we go. Good old AI tutor. All right, so where did I go wrong on the to equal that in my code? I hate it when they supply two different answers. It's just like, just give me like the best model. Drives me nuts. Anyways, here we go. Let's see what we got. ChatGPT 5.2. Thinking. Notice that it seems like these models get slower and slower. The smarter they get, the slower they get. But I have been having kind of some cool luck with. I do like ChatGPT. A lot of people have moved on to like Claude or Sonnet for coding, especially. But I do think ChatGPT is kind of cool. Like, I can upload zip files of GitHub projects, and it can unzip it in its like sandbox environment, and make a new Git project for you out of something. And it's doing a lot of agent-based tasks right through a chat, which I think is kind of neat. Offer 50 except for one sneaky typo. Ooh. Predicted minutes. Maybe I was just doing the squared part wrong. If I understand it right, maybe I just need to do this. Is this all I needed to do? Yep, shoot. Okay, so it was just this. Right here, I was doing... Yeah, that was not correct. Yeah, so that's why I was coming up with a huge number. So here we go. So cool. So what were the units? That's what I was curious. What were the units again for great question. Minutes, so yeah, I think this is kind of interesting. Let's give me a way I can copy that. So A is, yeah, just, it's this minutes per B is just minutes. Alpha B equals minutes. Alpha A equals minutes, and alpha B, sorry, alpha A equals minutes per degree squared, and alpha B is just minutes. So, cool. This could be a hot, a hot morning, hot morning. So basically, the building could be too warm and has to cool off, or warm up because it's too cold and it's wintertime. So this, yeah, it could be anything. So this is what I might save this for Model 1 tutorial and make it kind of complete on this Model 1. Then I think like what I want to do is just save this, because these are just kind of dummy files. Now Model 2, I'm just gonna, we'll learn on the fly. So we'll kind of have the same fake history for the And I think it would be kind of fun just to see what this will look like on the last, all these different, oops, this one's a little bit different. So model 5, I can't wait to get to this, but this will be getting into some machine learning-ish stuff. So where we actually factor in a weekday number, I think. Oh yeah, they're just doing a Boolean flag for Monday. Anyways, so we haven't got that far. Should be a couple more weeks. I might just zip through this questions. So I thought we talked about all this stuff. At what delta temperature do these two models begin to diverge significantly? What model would you think would trust for an interior zone with small setbacks? Probably the easy degree per minute model where it doesn't really change very much. Suggested model approaches for zones with experienced larger delta T is probably model 1. What we talked about with it's a curved. The physics has kind of a curved trait to it. So this is kind of interesting. So they're actually, it's kind of cool. So they're compare model 1, 0, and 1 predictions. They're doing this all in the same little program. So I'll have to think about this. So just the model 0, they're just doing the delta times the rate. They're giving us a generic rate, which is kind of weird. And then here's model 1. So, and they're even giving us that. So let's just see what this looks like. I might just delete it out of this code base, but it does look kind of interesting. Well, for here in our fake data, well, this is interesting too, because model 0 predicted 50.1 minutes, and this is model 0, 50.1 when we ran that code base, and then with the same data, even though it's fake, we got 53.8. So that is kind of cool. What I'm observing in the field, watching this stuff every day, that's kind of legit numbers. And then this is sometimes like the difference in error that I'll be off, 3-4 minutes, 5 minutes, that's 5% error, so this little piddly prediction being slightly more accurate could make for just enough percentage for better. I just want to see what this prints. Even though this is made up. Model 0, 10 minutes. Yeah, so this would be curved right here. And then this would be just, the linear triangle, kind of a flat line. This could be either significantly more accurate or significantly more error. It's a pretty big difference in the way that these models operate. So that is all I have for today. And next we can jump into this Model 2, which I absolutely know nothing about. So it should be kind of interesting. I'm kind of learning a lot on this little crash course, being a little bit more confident with setting up this optimal start from scratch and not using something that comes from a manufacturer, and perhaps even outperform the manufacturer in building automation. So anyone interested in keeping up on the Vibe Coder repo, I would love to do this in Python someday, but I did actually even update this yesterday, the quadratic model. I have probably 200 or more of these running in the field. I put in this that whole aspect of doing exponential moving average. to smooth out alpha A and alpha B. This was missing in the actual real code base. So I'll be going back through and then updating all of my stuff in the field. But yeah, it kind of helps to study things a little bit more in details, especially. So this is actually the Java, the program object. So this is where we calculate alpha A and alpha B, which we did in Python, and then I added in some extra, even the same code right here. So we added in a little bit more logic here. It might take me just a minute to find it. So this is like our updating our exponential moving average just on our alpha A and alpha B. There's our little equation in here. Anyways, I think it's this right here. So these are optional safety clamps. So we blend EMA instead of overwriting. So every time we update the model, we run an EMA across it to have smooth alpha A and alpha B parameters, which I think is kind of cool, which I think will help out keeping our minute calculations just a little bit more consistent. Because like just one more, I'm dragging this out a little bit further, but so like in model 0 we ran EMA across, that's how we're calculating our degrees per minute. And then model 1, we're only using an EMA for our alpha A and alpha B parameters in our closed form mathematics stuff. So we aren't using EMA across our historical data. That's what we're using quadratic regression. We're only using EMA here for our tuning parameters. So that's all I have for today. Hope you guys are getting something out of this. I sure am. Feel free to ping me if you have any questions, concerns, or comments, or else I will see you tomorrow.